Lesson 5.7 looks a little bit more in depth at our natural log functions and how we can use u substitution along with integrating with natural logs. So you already know that the antiderivative of 1 over x is the natural log of x. The absolute value is just because we can't take the natural log of a negative number. So that's why the absolute value is there, plus c. We can still do the same thing if we use a u substitution. So if we do a u substitution, that you wind up with 1 over u, the antiderivative is going to be the natural log of the absolute value of u plus c. So we'll just see some examples of that, of how our natural logs and substitution can get combined. So for the first one, we want to find the antiderivative of 1 over 2x dx. So probably the first thing you want to do is recognize that you have a function within a function, and we'll let u equal 2x. So that's going to take care of this. Du is going to be 2 dx. I don't have a 2 dx in the problem, I just have a dx, so we divide by 2, so du over 2. So when I plug this in, I get 1 over u du over 2, which of course we want to pull that 1/2 out. Remember, you can only pull out constants, don't ever pull out a variable. And then the antiderivative of 1 over u is natural log of u, absolute value. And then don't forget, you need to plug back in. So we have 1/2 natural log absolute value of 2x plus c. All right, number 2, we're going to follow a similar path on this one. We want to find the antiderivative of 1 over 4x minus 1. So again, we should locate that we have a function within a function. U is going to be 4x minus 1. So that's going to take care of this. Du is 4 dx. I don't have a 4 dx in the problem. I just have a dx. So this is going to be du over 4. So this will give us 1 over u times du over 4. We'll pull out that 1/4, so we have 1/4 antiderivative 1 over u du. And when you integrate that, you get 1/4 natural log absolute value of u plus c, and then we plug back in. Okay. All right, let's check out one more, and I think this is a definite integral. So we want to find the area of the region bounded by the graph of y equals x over x squared plus 1, the x-axis, and the line x equals 3. Okay, so I have no idea what this function looks like, but we've got some sort of function, and we want to find the area bounded by the region formed by the x-axis, the line x equals 3, and here. So this is what we're looking for, this area, whatever the function looks like. I have no idea. So to do that, we are going from 0 to 3, finding the area under the curve, dx. All right, get this out of the way because I need the space. So hopefully you recognize we've got a little function within a function here. I'm going to let u be x squared plus 1, and that will take care of this part. X squared plus 1, we're going to replace that with u. And then du is going to be 2x dx. I don't have a 2x dx in the problem, I have an x dx. So I'm just going to divide both sides by 2. So I get du over 2 equals x dx. So that means I can replace x dx with the du over 2. So this becomes 1 over u times du over 2. Now, I think I'm going to leave everything in terms of u rather than substituting back and doing x's. So if we do that, we need to plug these in. These right now are x values. I want them to be u values. So we're going to plug them in over here. So if I plug in 0, I get 1. If I plug in 3, I get 10. Okay, so now everything's in terms of u's. I'm not going to switch back to x's at any point. So let's see, I'm going to pull out that 1/2. 1 to 10, 1 over u du. And the antiderivative of 1 over u is natural log of u. Now I don't need the plus c because this is a definite integral, and we're going to evaluate from 10 to 1. So I'm going to plug in 10, so 1/2 natural log of 10 minus 1/2 natural log of 1. Okay. The natural log of 1, that is saying e to what power gives you 1? This is 0. The natural log of 1 is 0. Okay, so we have 1/2 times 0, which is just 0, so our final answer is going to be 1/2 natural log of 10. Okay, I want you to leave your answer like this. This is the exact value. Of course, if you do this problem in your calculator, it's going to give you a decimal answer. If you type in 1/2 natural log of 10, it should be the same decimal. We're going to check out a couple other logarithmic integrations in the next video.